Thank you, everyone, for joining this session. So, my name is Vinod. I work as a principal engineer with Arcism India Private Limited. Today, I'm going to talk about zero trust security and how you can implement zero trust security using the HashiCorp Vault and AWS IAM. So, a little bit about me before I start. So, I graduated in the year 2008 and has more than 16 years of development experience across various business domains like manufacturing, government, banking, both retail and investment bank in India and abroad. So I'm a certified in AWS and certified multiple times in Kubernetes, and I'm also an CNCF Kubstronaut. I'm a public speaker in Hashi Talks and various other events like AWS Community Days, Kubernetes Community Days, and CNCF meetups. So, as a part of the volunteer work, I'm also interested in spending my time on contributing to open source projects like HashiCorp, Terraform, CNCF, KEDA projects, and also a tech blogger. And I'm also an ambassador of Data on Kubernetes community. So here is the agenda for today's talk. So we'll start a session by understanding what the zero trust security is and its importance. Then we'll come to the overview of HashiCorp Vault, what HashiCorp Vault is all about, what is AWS IAM, followed by some best practices and in live demonstration. And in the live demonstration itself, I'll walk you like how you can integrate both HashiCorp Vault and AWS IAM to build a zero trust security model. Finally, we'll wrap up our session with some use cases and key takeaways. Now, what is zero trust security? So basically, this is a buzzword which we have heard quite often, the zero trust security, right? In a nutshell, it means trust nothing. Means when it comes to cloud native environment, so you need to have a particular security model which is not going to grant you the implicit permission. So everything is denied. You think of a system that you have created which is not giving you the explicit permission to access it. So by default, everything is denied. And if you want to provide some access to the user or a system, you are providing the explicit permission to that user or the system. Let me take an analogy. Let's say you are a famous Hollywood actor who is traveling from country A to country B, and you are at the airport, right? So the immigration officer who is sitting at the airport is verifying your passport and your visa. Now, think that passport is nothing but your identity, your username, password, or your certificate. And that visa is nothing but your authorization checks, means for how many days you are traveling, or whether you are traveling on a right visa or not, whether it's a work permit or the tourist, right? Now, think the same approach is followed when it comes to the cloud native environment, cloud native applications. So there are some principles or the tenets which this zero trust security follows. That is the use of explicit authorization. Like I mentioned, so nothing is implicit allowed. So you need to provide the explicit authorization to your users and the system. Second is once a user or the system gets authenticated, what's next? Like, are you going to provide the full access? No. Like, you should be providing the only the limited permission, only the required permission. Let's say if your users are required to upload an object on S3 bucket, you should only grant the permission to upload the object, not to delete or list the bucket. So that is your RBAC or the role-based access control. The third about is the network security. So now the network security is again very critical. So let's say if you have a backend system which has to communicate to your database, and your database is listening on a particular port, let's say 3306, you should only open that particular port and close all the ports. Not just that, you should ensure that your traffic is completely encrypted. So you should follow the encryption in transit. You should also ensure your data is encrypted or traced. So all those talks about your network security. Finally, assume the security breach. Means nothing is permanent, nothing is a well good solution. You should time to time log your, or you should perform your audit logging, and you should anticipate the failure and improve your systems. Now, when it comes to importance of zero trust security, especially on the cloud native applications, the security is pivotal over here, because unlike the monolithic applications, which is running on a single server, your cloud native applications, which are typically the microservices applications, are scattered or distributed across multiple servers. It could be on a single cloud, it could be on multiple cloud, or it could be on-prem solutions. So your point of failure, so this leads to the increased complexity, and your point of failure is also more. So you need to ensure that everything is tied together, secured, and it's well connected. So, and then is the dynamic scaling, because when it comes to cloud native applications, you have noticed that all the resources are ephemeral in nature. Your pods are going up and down. All your pod IP addresses are all ephemeral in resources. The underlying infrastructure is completely ephemeral in nature. So you need to ensure that your zero trust security is met over there also. Now, let's talk about the HashiCorp Vault. So HashiCorp Vault is an identity-based secret management tool. So let's say if you're in your application, you want to manage some certain secrets like the API keys or the database credentials, you can make use of HashiCorp Vault and leverage architecture. So it provides a centralized mechanism where you can create certain roles and access control lists so that you can manage who can access, which users can access your vault and can make use of those vault features. So there are some of the features which HashiCorp Vault offers is, like I mentioned, you can use to store the sensitive information. Your sensitive information like your API keys, passwords, certificates, tokens, anything. You can also make use of dynamic credentials. So this is the beauty of Vault, where you can use of dynamic credential. Let's say, for example, if your application has to communicate to the other system and you don't want to store any static credentials over there, you can use the dynamic credentials, and it will generate a short-lived temporary credentials which you can use to connect to the other system. Finally, you can also use HashiCorp Vault to generate the certificates. If you want to encrypt your traffic, you can create the certificates, manage them with the help of the Vault, and then use the HashiCorp Vault also to control some access policies, like I mentioned, and also it can be used for data encryption. If you want to encrypt your data, you can use your HashiCorp Vault also. So let's get into the AWS IAM, which is very critical, which is a global service from AWS. It's an identity access management service from AWS. If you want to access any of the AWS resources, let's say if your users wants to access or any particular system wants to access, you need to have a global identity created at an AWS IAM service. So AWS IAM is a global service, not specific to any particular region. So you can provide some fine-grained access to a user, to a role, and make use of temporary credentials or the long-lived credentials over there to access the certain AWS resources. Now, there are some features which AWS IAM also offers. You can create the users, you can create the roles, and then also you can create some groups. Group is nothing but your group of users, and then you can assign the role to that group. And your role will also tell, like as best practices, you can create only the least privilege, least permission privilege to provide the granular access. You don't want to give a full access to a particular AWS services, let's say S3 and EC2. If you want, you should always provide the granular access to AWS services. For better security checks, you should also configure your AWS access with the multi-factor authentication. So that feature is also provided by the AWS IAM. Lastly, AWS also IAM also offers AWS Role Anywhere. So AWS Role Anywhere is something like, let's say, if you are accessing, if your cluster is outside the boundary of AWS itself, AWS Cloud itself, you can still make use of the AWS credentials, role, and temporary credentials by leveraging the AWS Role Anywhere. So this we will see in a couple of slides later. Now, some of the best practices we should always follow here is the short-lived credentials. We should never ever use for a long-lived credentials because they creates a bigger blast radius. So we should always create the short-lived credentials and make use of it whenever we want to communicate to other systems securely. Then we should always use of the token rotations. You should always automate the token rotation so that they are not expired. All your SSL certificates also you should or rotate well upfront, rotate it. Then some of the best practices talk about the audit logs. Like you should regularly audit your access, your logs. You should also audit time to time so that any loopholes will come to know and you can improve your better security posture. Then you should always follow the principle of least privileges. If your users are supposed to do only a particular task, you should only give the required permission, not the full permission. And finally, make use of multiple factor authentication wherever it's possible as a best practices, because no one can sniff your account, no one can steal your identity, only you can make use of it. Now, in today's demonstrations, I'm going to show you like how you can make use of the zero trust security by using this HashiCorp Vault and IAM. Now, this is the architecture which we are going to follow in today's demonstration. So if you see here, the ultimate goal We have a cluster running on the AWS cloud, and this is the application which is running. And this application has to upload certain files to this S3 bucket. Now, there is no credential currently with this AWS to this pod. So how this application is going to make requests is here. When we install the Vault in a Kubernetes cluster, so we will get certain applications of Vault, like the Vault pod as well as the Vault injector. So application first, when deployed, will get a service account token it will get. The service account token will be passed to the Vault, and in exchange of the Vault will give you the Vault token. And what the Vault will do with the help of the AWS secret engine, it is going to make a call to the AWS IAM service. And whatever the policies are associated with that AWS IAM policy, let's say in this case, we want to access S3 bucket, AWS IAM will generate the temporary credentials, short-lived credentials, and will pass it back to the Vault. What the Vault injector will do, Vault injector will offload a lot of heavy lifting from the application side. It will pass that credentials, the temporary credentials, back to the application, and your application will make use of those temporary credentials to eventually upload certain data to the S3 bucket. And after a certain time, when the lease period expires, that token will automatically get expired. Now, next time, if that application wants to perform the same operation, it will again communicate to the Vault pod. Vault pod will generate the token temporary credentials. So this is what we are going to see here now. I will give a walkthrough of it. So like I mentioned, so this is on Kubernetes cluster. First of all, we need to install a Kubernetes cluster on our infrastructure. So then we need to add the repo for Helm charts for the Vault. And then with the help of the Helm, we should be installing it. So before I start, right, so if you see here, I have created a namespace for Vault, and inside that namespace, I have with the help of the Helm, I have installed the Vault, and in the namespace of Vault. Now, when this Vault is installed, it is going to deploy the two pods. First is a Vault pod, second one is a Vault injector. And first, we need to do some configuration as soon as a Vault is running. Once a Vault pod and Vault injector are in the running state, but we need to initialize it, the Vault, so that we can configure it. So this is just a one-time process, what we have to do here. So with this command, that is Vault operator init, we need to initialize it. So the moment we initialize it, the Vault is going to give you certain unsealed keys as well as the root token. We need to ensure those tokens are kept securely, because we may require it. Whenever we have to unseal it again, we require those tokens again. Now, once you get and initialize the Vault, the second step what we have to do here is we have to enable the authentication. So the second is our Vault is running in the Kubernetes cluster. So whatever the workloads which are going to run, let's say any pod or any service account, they have to authenticate themselves with the Vault server. So for that, we need to create a trust between the Vault and the Kubernetes. So for that, we need to enable the Kubernetes authentication by running this command, that is Vault auth enable Kubernetes. So this will ensure that a trust has been created. Now, if I show you over here on the UI side of it, so once you run the Vault, you will see the Vault server running. Now, the moment you create enable the Kubernetes authentication on the Vault, you will see a Kubernetes authentication method. Now, any workloads which are going to run should be able to communicate, but we can also restrict based on namespace and service account, which I'm going to demonstrate now. Now, once you have enabled the Kubernetes authentication, the second step is you need to get the host of the Kubernetes, where the URL where your Kubernetes cluster is running, and then create this configuration. You need to create a configuration by passing the JWT token, the service account token of the Kubernetes, the host URL, as well as a certificate of the Kubernetes. Now, with these three information in hand, you are going to configure the Vault, and now Vault and Kubernetes are enabled, like they are a trusted partner with each other. Now, once that part is done, the third step is to create an ACL in the Vault, create a service account, Kubernetes service account, to configure the Vault. So what we have to do, we have to create one access control list on the Vault side. So for that, we have given a name like dev role, capabilities at read and list. and we'll pass this information to this dev policy.hcl, and then run this policy. So what essentially it will do, it is going to create an access control list, a vault access control list, something like this. So this policy will tell who is going to access and what capabilities they have. So here we are given the capabilities are read and write permission. The second thing is we also need to create a service account. This is a Kubernetes service account we have to create. Now, what the service account will do, any pod or any workload on the Kubernetes cluster side has to make use of the service account so that they can make use of the Vault tokens. They can authenticate with the Vault server successfully. If you're not using the service account, or if you're using any other service account, your workloads will not be able to authenticate. So we need to have one service account also created. Now, one thing which I want to highlight here is if you are on an older Kubernetes version, let's say on 1.24, earlier, the token was created automatically. Now, if you are on a higher Kubernetes cluster, you need to create a token for the service account explicitly. So that's what this command is doing here. Now, we have an access control is created. We have a Kubernetes service account created. The next thing here is to bind these together to this dev role on the Vault side. So what we have done here is we have created a role, auth Kubernetes role, and we have named it as dev role, and we are passing the service account name and the namespaces. So in this case, a Vault server is running in the Vault namespace, and it could be any other namespace also you can whitelist, but here we are given the Vault namespace, and then we are passing the dev policy also, the Vault ACL. And then with this information in hand, we are going to create a dev role on the Kubernetes side. So this is what, once you perform that operation, you will see a dev role created on the Vault side. So the next step that we have to do here is we need to create an IAM user on the AWS side. So I have already created, in the interest of the time, the IAM user. So this is IAM user I've already created. So you can just go and manually create, or you can use an API to create it. And in this IAM user, what I have given here is the certain policies, because this IAM user is going to create some temporary credentials. So I've given certain policies over here, that is create additional IAM users and all. So which we'll see over the demo. So once you have created the IAM user and get the access key and the secret access key, you need to configure that with the Vault once again. Now, this is a step where you are going to pass. You are going to create a trust between the Vault as well as the AWS IAM. So till here, we have everything. We have done with everything. Now we need to configure an AWS secret engine so that Vault can make use of AWS secret engine to generate the temporary credentials by making a call to the AWS IAM service, and can pass that token back to the application. So for that, we have we have to run this command, which is Vault secrets enabled AWS, and then configure the AWS root credentials with this. Sorry, AWS user credentials with access key and the secret access key, and pass the region. So this will ensure that these secret engines are been configured very well. So if you see here, we have a secret engine which got created here with the dev role. So it has a permission now. So if you want to test, we can test now also. Let's say if I generate some temporary credentials, it will go and make call to the AWS IAM service and will generate the temporary credentials. So if I go and refresh it, you will see the Vault has created a temporary user with the credentials. This is access key and secret access key it has generated, and this credential will pass back to the application. Now, so once everything is done, it's time to test our application. Now, the whole code is available over here, but let me give a walkthrough of it, how it is going to work. Now, this is the application which we are going to run in this demo. Now, if I zoom in, so I've created a config map, and I'm passing the Vault address over here, and the Vault role, which is the dev role, which is this role, which is this dev role over here. And I'm passing the bucket name where this application has to put the object. I'm passing the region also. Now, this is the application which is going to work. Now, if you see here, we have created a service account and we have binded the service account to this application, which is Vault SA. Now, what this code is essentially going to do here is, with this service account, it is going to make a call to the Vault. And in exchange, it is going to get the Vault token. So this is that path. It is going to get the, first it is taking that service account token. And in exchange, it is going to make a call to the Vault server. And in return, it will get a Vault token. And that Vault token, we are going to pass it. And then using that Vault token, it is going to make a call to the AWS service engine. And then it will get a real temporary credentials. So if you see here, with that Vault token, it has made a call to the Vault address to the service engine. And in return, it has got an access key and the secret access key. And with that secret access key and secret access key, it is able to do whatever the job it is supposed to do. So in this example, we are uploading a file to the S3 bucket. So it is going to do that. It is going to create a one dummy file and it is going to upload that dummy file to the S3 bucket. So this is what it is going to do. Let me run my application. Let me deploy this application. So if you see here, like I mentioned, so when we set up this Vault, we'll only have the Vault pod and the Vault agent injector here. So right now there is no application running. So let me run this application. Okay. Yeah. So I've created an application, deployed the application. Now it is in the running mode. Let me check its log now. Yes. So if you see the logs, so it has first made a call to the Vault. It has got the temporary credentials. It has created a temporary file and it has successfully uploaded to the Vault. Oh, sorry, the S3 bucket. Now, if we see the bucket, you will see an object which got successfully uploaded by application. So this is how it is going to create a temporary credentials. Now, if I go back to the IAM users, you will see a new IAM user got created. And this is just a temporary one. So this is how it is going to work with the zero trust security model. Now, there are some strategic implementation. Like you may be wondering, like, what if my cluster is not within the AWS cloud itself? What if the cluster itself is running outside the purview of the AWS cloud, or if it is in multi-cloud, or it is a hybrid cloud, right? You can still make use of this model because that's the beauty of the AWS and the Vault side. AWS provides something known as the AWS role IAM role anywhere. So what essentially you are going to do here is, so this is a typical architecture. If you see, this is on the left side, you will see an on-prem cluster, which is completely outside the boundary of AWS cloud. And then which has nothing to do with AWS over here, right? And on the right-hand side, you will see an AWS cloud. So what essentially you need to do, you need to create an IAM role anywhere, which is one layer before, IAM role. And you need to create a trust between the Vault server and the IAM role anywhere. So what this trust will essentially do, so whenever the request is coming from the Vault, so IAM role anywhere knows, okay, this request is genuine and it is coming from the authorized certificate authority, which is a Vault in this case. And based on that, it will go and, make call to this IAM role, whatever the IAM role we have configured on the IAM role side, and the policy which is going to be attached on the IAM role. So that temporary credential is going to generate and pass it back to the application itself. And that application then make a call to the S3 or whichever the AWS services it has supposed to do. So that entire, the flow is going to be encrypted and the zero trust model over here. So you can use both Vault as well as the AWS IAM role in this case, whenever, if you're not within the AWS cloud itself, if you are outside the boundary of the AWS cloud itself. So these are the best practices also which you can follow. Now, some of the use cases which are a good fit or here in this case is the daily backups. So let's say if you have any solution where you want to, back up your daily sensitive information to the cloud, you can follow this approach also, where you have to follow, daily backup. You can do it with the temporary credentials. Then you can also follow this practices when it comes to disaster recovery. You can have you can keep this data on a cloud or in a different cloud also with this approach on a time-to-time and you can recover it during any disaster recovery case also. And if you have any info, if you're following any hybrid cloud or the multi cloud, if you're not on the completely AWS cloud, you can make use of this approach very well. Yeah, so these are the key takeaways which we learned in this talk. That is, we started with the problem is the cloud native applications. Then we get into zero trust security models and why it is important in the modern applications. Then we have seen the live demo and how you can integrate a vault within AWS IAM role to provide a zero trust security model. We also got a glimpse of how you can make use of AWS IAM role anywhere if you're not outside, if you are completely outside the boundary of the AWS cloud, and some of the best practices and the use cases over here. Now, here are the reference links which I have used in this demo, so you can make use of it. And these are the recommended links which I would recommend to go and read. Yeah, so if you want to connect with me, so here my QR code, you can connect. So yeah, thanks for joining this session. Thank you.